Alright, hello everybody. This is the tutorial that wasn't recorded during class. We'll jump right into it. Just to go over those diagrams explaining how to sort of break down how to think about Grasshopper. The effect that I had shown you was the bubbles on the surface of the coffee, and just looking at it in really basic terms, showed you how to break it down into its sort of basic components or elements. In this case, it's the cup itself, or the boundary condition. There's the foam, which is sort of doing its own thing and avoiding the center and attracted to the edges. There are large bubbles and smaller bubbles, and they're each doing something. In this case, large bubbles looks to be more inclined to be near the center versus the smaller bubbles, which are closer to the outer edge. Remember, this is just sort of an abstracted way of looking at this effect, so don't worry too much about getting it super precise. So again, this file is uploaded online. Please do a better job of diagramming than this in your assignment. Looking at the Grasshopper file, this is the result that we're trying to achieve. Again, it's abstracted, but it's an effect that you can play with in Grasshopper. So starting off, we can look at, we could go backwards, but I suppose since you've seen it already, we'll start at the beginning and move our way forward. What we started with initially was a curve. What you guys will need is a sort of proxy geometry that you can play with and input all these Grasshopper things into. That may be a set of curves or a surface or whatever. In this case, it's that circle right there. And what I've done to actually be able to populate the inside of it is turned it into a surface. So we took a curve, and in this case used a boundary surface widget and converted that curve into a closed surface. I suppose for the tutorial's sake we can show the full names and turn the icons off so you guys can see what's happening. Now all my pretty organization is gone. Okay, so moving forward, as I have labeled here, what we're trying to do is populate that surface that we just created. So to do that, we've used a populate geometry widget. Again, double clicking to pull up this. When you're doing Grasshopper, just type something in that sounds like what you want to do, and all of these options will pop up, and hopefully you recognize some of them and know how to use some of them. Hopefully you don't and you explore some of them. That's the best way to learn. In this case, we use this widget, the populate geometry, which you see right there. Again, there's inputs and outputs. So on the input side, we plug in our geometry, which is the surface, the number of points we want to add to that surface, which we use a slider for. Again, double click, slider. Well, in the case of numbers, remember that you can just type in any number and it will come out on a slider. And remember that it's sort of that rule of the next closest 0. Is that what we decided on? So in the case of typing in 25, it would run all the way up to 100. If we type in 5, it will only run up to 10. So that's the way those things work. They scale for you. Given that we had a lot of bubbles on that surface, we went ahead and tossed in 100 points. moving forward, we noted that the bubbles and foam were sort of attracted to the edge of that cup. So in this case, that's that initial curve that we had way back there. So what we can do is get all of the points that have populated that surface, which we can look at here. So this is the geometry. Let's turn off everything else so you guys can see this. So this populate geometry, if we turn that on, you'll see that that interior area there has now been populated with points. They're random. In the other definition down here, if you remember, we populate it with a more grid-like system, but for now we'll just focus on this. And what we're going to do is take those points, and what we want to do with them is move them. So start off with that move widget, and we know that we want to move this geometry, i.e. these points, and we're going to need to move them in a certain direction and a certain distance. And this mess down here is all about creating that direction and creating that distance. So the first thing we did was back here, populating, sorry, in this area around the circle. Let's turn this guy off. So what we did to this circle then was we divided it, and by doing that we can divide it a certain number of times, in this case 47. And what you see there are all the points, and what this is doing is it's going to allow us to use this next widget, which is the closest point widget. And what it will do is it will take the point, i.e. the list of points from up there, so all of those points within the circle, we're going to send them into a list, and then we're going to move them, or sorry, this widget will find the closest point on the curve to that point. So if we show this, all you're going to see is those exterior points lit up because they are the closest point to one of these points. And there is a way of determining which one is which, and how you can say that this point here is closest to that one. We're not going to go into that, but if you use those list management tools that Matt went over, you should be able to figure that stuff out on your own. So now that we know which point is closest around the circle to the points on the inside, what we can do is draw a line between those two things, and that's the vector between 2 points. Essentially you take the point from that list and a point from this list, i.e. one of these points and one of those points, and plug it into this widget, and what you will get is a vector. So what we can do is display that vector. This is just a handy little widget. It has no outputs, but it does show you which direction those vectors are pointed. So hopefully you guys can see those green arrows there on the screen. Each one begins with one of these interior points and ends at the closest point on this curve. So now that we have this point, we know that we want to move it in this direction, i.e. towards the circumference of the circle. What we want to do is make sure that it doesn't move all the way out there. So if we were to just punch in the vector, it would likely just move all of these points right to the edge of the circle. What we can do is find the halfway point along all of these lines, so say right there and right there, and that would cause all of these points to sort of disperse from the center of the circle and move towards the outer edge. So what we do then is just taking, this is the panel tool if you don't remember, by taking those vector values and dividing them by 2. We're finding the halfway point of each of these. And essentially what we're saying then is we want this point to move halfway to that point with this move widget. So that's how we get all of these points. Let's turn them off now. That's how we get all of those points closer to the edge of the circle. So what we can do now is start to create those bubbles on those points. Let's have a look. So we don't want to look at the foam. Search tone. So as we noted earlier in those diagrams, the larger bubbles tended to be more centrally located, whereas the smaller ones were generally found closer to the edge. And again, that's just looking at this and abstracting it more or less. Larger bubbles in the middle, smaller bubbles around the edge. So what we can do then to create those bubbles is we're going to use a sphere widget, and if we were to just punch in the like a random radius, we would get each one of these points with the same size of sphere. So just for example's sake, we can say 1.5, and we'll plug that into the radius. And if we turn that guy on, once Grasshopper acknowledges it, each one of those points will have a sphere of the same size. So that's great. We now have bubbles within our cup, but what we want to try and do is show some differentiation between bubble sizes. So what we can do then is measure or use the values that we've created, that is the distance between the outer edge and that point, and use it to create radius values for us. So if we take the distance, that's this guy here, measure the distance between these geometries. Let's turn off those spheres. If we take the distance between those points and the, where's this guy going? And the closest points, which is where they're moving to, if you recall, we can again divide that number by whatever number you like. It depends on how large you want those radii to be. In this case, we use 10. This could also be substituted with that remap function that we used down below, if anybody remembers that. But we'll skip that for now. In this case, the division works fine, and what we get is a number or a value out of here, which we can then use to determine the radius of our sphere. So basically all this is doing is it's saying this point is X amount of units away from the curve, so it is size A, and this unit is Y units away from the curve, so it's size B. And all we're saying is that the further away it is, the larger the sphere is going to be. And just to sort of finish this all off, we do have our spheres then with varying circumferences, radii, whatever, because it is a sort of surface texture that we were looking at originally. We don't want all of these halves of spheres underneath. So just like what you would do in Rhino, you can do a sort of Boolean. This is a solid difference widget. Essentially, you take the first rep, i.e. our spheres, and basically chop them by the surface, which, if you recall, we created way back here in the boundary surface widget. So all that does is it essentially takes these spheres and chops them in half. So now we have that bubble condition. So that's essentially what we covered in class. I'm not going to go over the foam and how we pull that up. It's essentially a metaball widget that is just essentially like cut away until we got the shape that we needed, and that's probably not the best way to go about it, so we're better off not talking about that. But what we can do now is one more look at the image sampler example. And again, this is all out of whack because we changed it away from icon mode. So again, what you guys are going to need to do this, and again, remember, we're taking this image and sort of applying it to an effect on a surface. You'll need your proxy geometry. Again, it's the same thing, the curve or a surface. Again, we're starting with the curve and created a surface from it. To populate this surface now with just a sort of grid, we're going to go divide surface, and what this guy does is, oh, that's a lot of points, so you probably can't see, but essentially divides or populates the surface with points along UV coordinates. We've got 250 points in there in each direction, so that's a lot. But the more you have, the more resolution you will have in the end with your image sort of recreation. So by using those points, we're going to find the surface closest point, or use the surface closest point widget. And what we can do is, taking those UV coordinates and where they correspond to the surface, plug them into the image map. If you don't remember, if you double click on this guy, some options will pull up. And like we said in the tutorial in class, just try and stick to these sort of default options. I suppose I shouldn't say default, because I believe you have to click on the color brightness and the interpolate, check the interpolate box, and we'll run with that. And that will all be fixed as long as you use the domain widgets. So we're going to set the bounds coming out of there and plugging them into the source of the remap numbers. And with this, we're going to construct a domain. So what this is doing is, if you recall, we're going to create that image by varying the radius of a circle, or the circles that are based around all those points that we created. So using the circle function or widget, we're going to use the points on those 250 points in every direction grid. We're going to plug those into the circle, so that means we have a lot of circles, and the radius is going to be influenced by this image map. And just to ensure that the radius of these circles doesn't get out of hand, we're going to construct a domain and remap all the numbers that come out of here. So this guy's going to shoot out, I think in this case it's not too crazy, it's pretty reasonable. These are all within the range of like 0 to 1, which is okay. But sometimes you might have values that shoot up way beyond that, and it's just a mess. So we could have circles that are actually larger than this boundary circle here. So what we're going to do, just as a sort of failsafe, is make sure that every value in here is scaled between 0 and 0.75, because 0.75 is the largest radius we want to deal with on this surface. So if you plug them in this order and send those values up to the radius of the circle, you should get something that resembles your image map. There we go. So I know this is really quick and you can't ask questions over the internet. Well, I guess you can, but not in real time, and that's just what you're going to have to deal with. But hopefully that helps, and feel free to email us with any questions about the tutorials or the files that we've uploaded.